We did something related to the the passive filters, which was low pass and high pass in the last tutorial. So just a quick recap, real quick on that. We started from having passive components, which is R, C, and L. We said that if we have a low pass passive filter, then that will allow the frequencies which are below the cutoff frequency. And when we said that when we have a high pass passive filters, it will allow the frequencies which is above the cutoff frequencies, right? Then we try to build upon on the basic circuit diagram. For a low pass filter, it would be a RC circuit, a resistor and a capacitor, and you are taking output from the capacitor. For a high pass, it would be a capacitor and a resistor circuit, and you will be taking output from the resistor, right? So these are the few things that we discussed in the last tutorial. Then we talked about that if we wanted to have a sharp cutoff range, we can increase the order of the filter, right? Which is just by cascading more number of these guys and just adding them in series, right? So what would happen is that from the negative 20 dB per decade, you'll probably reduce down to negative 40 for the second order. Then for the third order, you'll go to like negative 60. So that's how you can design the filter if you want sharp cutoff frequency ranges. So that was all about passive filters in the last class. Now we're going to touch upon directly into the active side of our high pass and low pass filters. And there were some formulas for that. I hope that you have uh, take a good note of that, and I have also posted the recordings of that. At that again. So the next thing that I'm going to do is we are going to start with the passive side, sorry, the active side now of low pass and high pass. I'm going to start from the active low pass filter. As stated in the last session as well, the difference between active and passive is that active is with op amps transistors, passives are with just resistors, inductors, and capacitors. Active allows you to provide a gain, passive don't provide you any gain. Active is good in terms of the loading effect, that your output circuit is basically isolated from the input circuit. There are three major key differences that decides to use active filters rather than just passive filters. All right, so as we all know that uh, I'm gonna put a quick question over here, or maybe just someone can tell me that if that is my Vn and that's my V out, what is the gain of this circuit? It's just a one, right? Because it's a and it is called a voltage follower, right? It just follows whatever you are trying to input at that point. So in order to implement an RC circuit or a, I would say, low pass filter, I could use this circuit similarly. And what I would do is apply the knowledge that I have of the low pass filter, which is nothing but a resistor and a capacitor. We already know that that's your low pass filter. You can use the output node, connect that with the positive terminal, and just apply an output from here, right? So I've done nothing, but I've used the same understanding that we have developed for the passive low pass filters, which is a resistor and a capacitor. And I've tried to just implement an active low pass filter using the same circuit and putting that as an input over. The good thing about this is that now the output is isolated from the input because it has an op amp in the center. The second good thing is that whatever output I wanted to have would have eventually the same value as the input because there's like no gain value right now. But once I implement a gain value to that, then the output will be amplified as well, right? So it's getting into these steps. The first one was just the basic RC, then the CR, then going into the active side for the low pass, right? All right, so if I would add just, I'm going to change that to more realistic approach, and I would add over here some grounding, some resistor, and some resistor over here. And I'm going to say that this is my RF, this is my RI, This is my normal R, this is my capacitor, right? So the gain formula now would be 1 plus RF over IRI, right? So over here, that's nothing, but you are trying to implement some gain, right? That's your gain part. That red part, or maybe that part over here, is your filter part. That's your op amp, which is trying to isolate from both sides from the output, right? So just try to integrate the three different components and draw an active low pass filter. Quick question on that. So normally you would see, if I try to rearrange this all thing, normally you would see in textbooks and everywhere, that circuit is still going to work the same way, which I'm drawing right now. Is this circuit, which is a negative side, a positive side, a resistor, and supplied with V in. It's R, it's R1 grounded, it's RF capacitor, and that's V out, right? So it's there is like slight difference in that. We are just trying to put the capacitor on top, but this is what normally you would see in normal textbooks, and that is what an active low pass filter would look like. All right, the gain formula for this circuit is again 1 plus RF over RI. Yeah, and you would probably know the cutoff frequency formula, which is FC is 1 over 2 pi RC. And what else should I tell you? Yeah, that should be good enough. All good. I'm gonna delete it all and I'm gonna give you a question over there. It will be very straightforward one. So yeah. So suppose I have a resistor, a feedback, a circuit with negative, positive, positive with a resistor again, capacitor over here. That's my output. That's my input over. That's my ground. It's 10 ohms. It's 0.1 microfarads. It's 1 ohms is 4 ohms, right? And it's an active low pass filter. Tell me the value of cutoff frequency and tell me the value of gain. Straightforward. Yep. 4K as a feedback, 1K on series to the inverting terminal, 10K to the non-inverting terminal, and zero point 0.1 as the value for the capacitance, microfarads. answers. Cutoff frequency is, so FC is 159, just hertz or kilohertz? 159 hertz, and the gain is what? 5, right? That's a straightforward question. Anyone who is unable to solve that, probably no one would step up, but yeah, you can, right? So it's 1 over 2 pi RC, right? And 1 over 2 pi resistor value is what? Over here, you have to use this circuit part, right? Which is over here for the cutoff frequency type, because we have done similar questions to this. Now it's the op amp is just trying to amplify whatever we are trying to input, right? So we are basically cutting off the actual part of the FC, and we have implemented that as a passive circuit, and now try to just join together with the active part. So that would be 10, what's that, 10 kilo and zero point 0.1 micro as the capacitance value. That will give you 159 hertz. And for gain, it's just 1 plus RF over IN. So you can use the gain equation from here. 4 over 1 is 4, plus 1 is going to be 5. So that's 5 for gain, right? So that's how the basic formula would work. And that's how you can apply the active low pass filters. I want you to draw active high pass filter now on the basis of the knowledge that we have done so far, not the textbook circuit, right? So we done passive low pass, then we did passive high pass. Now it's about we have done active low pass. It's about designing active high pass. Design an active high pass filter. So it's nothing. It's just you have to just add the first thing which you already know. You know that I have a capacitor and a resistor like this combination, right? For the passive thing, right? I'm just going to use that and input that to one of my terminals. And for negative side, I'm going to apply the same thing, which is the gain part. And yeah, that's enough. That's a good enough circuit. So the same knowledge of the passive uh, high pass, I would say, integrated with the knowledge of how we can have a gain in the circuit, right? And then integrating just the op amp in that circuit. There are three components again, right? So it's not about how you can draw it. You can draw it with a number of ways, but probably this is how you will remember it forever. That it's not something that you have to think what should be my value of RC, where should I place that. It's just about if you know the basic things of the passive side. With that being said, this is how the circuit would look like. I would probably draw it a little better, I would say. That's my C, that's my R. This is where I am inputting at the positive side. This is going to be a ground connection. I'm going to use a resistor to the negative side, resistor, feedback from that, and you can draw the ground bus if you want to, which is plus minus out, plus minus and yeah. right? So again, the circuit would probably work in the